least get this thing going properly. Where is this? Oh, so this is bizarre. Hold on. There we go. Whew. It's acting very oddly. Frankly, I'm not impressed. Okay, enough of this. Cancel. Shut up. Oh boy. Okay. Today we'll be doing the end of chapter 3, and so therefore, chapter 3 will be due next, I guess, the 8th, next Monday, the 8th. 3.7, product to sum and sum to product formulas. We'll also move on to 4.1, right angle trigonometry. Okay, we start. Oh, I'm sorry to say, I forgot to mention. Right, this this Zoom session is being brought to you by the fractal, single point fractal, intimate orb. All right, here we go. Product to sum and sum to product formulas. We had last time some formulas of cosine and sines of sums and differences. Cosine of a sum is cos minus sine. Cosine of a difference is cos plus sine. Sine of a sum is sine cosine plus cosine sine. Sine of a difference is sine cosine minus cosine sine. Now, if we add these two identities together, cosine alpha plus beta plus cosine alpha minus beta on the left, and on the right, sine alpha sine beta cancels, and we're left with 2 cosine alpha cosine beta. If we subtract these, this minus this, this minus this, and this minus this, the coses cancel, and we're left with cosine of alpha plus beta minus cosine of alpha minus beta equals minus 2 sine alpha sine beta. If we add these two formulas, on the left we get sine alpha plus beta plus sine alpha plus minus beta. The cosine sine cancels, and we're left with sine of the sum plus sine of the difference is 2 sine alpha cosine beta. And if we subtract them, these terms cancel, and you get 2 of this. So you get sine of alpha plus beta minus sine of alpha minus beta equals 2 cos alpha sine beta. Now, this is not listed in the book, but I call it the sum and product identities. The thing is, you can then turn it into 2 separate sets of identities, the product to sum identities and the sum to product identities. To get the product to sum identities, take all these and divide throughout. Well, this throughout by 2, this throughout by -2, this throughout by 2, and this throughout by 2. Put these on the left. So cosine of alpha cos beta equals 1/2 of cosine of the sum plus cosine of the difference. Here, dividing by -2, get that sine alpha sine beta equals minus 1/2 of cosine sum minus cosine difference. There's a minus, so this makes this the oddball. If you divide by 2, then sine alpha cosine beta equals 1/2 of sine of sum plus sine of difference. If you divide this by 2, you get cos alpha sine beta equals 1/2 of sine alpha plus beta minus sine of alpha minus beta. These are actually pretty much the same. Just a second. They're pretty similar. All right, fine. These are called the product to sum formulas. So here you have products of cosines and sine equal plus or minus 1/2 of sums and differences. I really think of these more like averages and half differences, but whatever. Now, if we go from here and call this alpha plus beta u, and call this alpha minus beta to v, then you can get that alpha is u plus v over 2, the average, and beta is u minus v over 2, the half difference. So putting u in for all these alpha plus betas, v in for these alpha minus betas, u plus v over 2 for the alphas, u minus v over 2 for the betas, and these all turn into these equations, identities. Cosine u plus cos v equals 2 cosine average plus cosine times cosine half difference. Cosine u minus cosine v equals minus 2 sine of average, sine of u minus v over 2. Again, we have a minus here, which makes this particular identity the oddball. Sine u plus sine v is 2 sine average, cosine of half difference. Sine u minus sine v equals cosine average, sine of half difference. These are the sum to product identities. Now, sum to product identities imply, among other things, beats. If you take two sine waves, such as a sound, boom, boom, and play them at the same time, so that the waves add up in the air. So the sum is sine of AT plus sine of BT, and that's sine plus sine is twice sine average cosine half difference, twice sine average AT plus BT over 2, cosine of half difference AT minus BT over 2. So you get y equals 2 sine A plus B over 2t. So this is the average frequency. And cosine of A minus B over 2t. This A minus B over 2 is the beat frequency. What happens is that you get this sine wave being multiplied by this. So I guess this is the cosine wave, really. I should put the identity mark here. So you get this wave which rises and falls and rises and falls in amplitude. And you get a kind of, and that's called a beat frequency. It's wow, 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 and so on. Let me see if I can do this. I used to be able to do this. Whistle and hum at the same time. Let's see. There you go. You got a definite beat in there. Now, I'm told that in the old days when piano tuners were using analog methods to tune the analog device called a piano, you'd have a middle C tuning fork, hit it, and hit the C on the piano. And if he hears a wow, 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 wow sound, a beat, obviously that means the piano is out of tune, so he tightens it or loosens it until it stops beating. And that is when you get when the piano is in tune. Now, some for examples. All right, here. Sine of 4 theta cosine 2 theta. So sine times cosine. We're going to need the sine times cosine formula, a half of sine of sum plus sine of difference. So, all right, a half sine of sum, 4 theta plus 2 theta, plus sine of the difference, 4 theta minus 2 theta. So it'll be half of sine 6 theta plus sine 2 theta. Here we have cosine 3 theta times cosine 5 theta. All right, that. All right, so again, product of sum, cosine times cosine is half of cosine sum plus cosine of the difference. Okay, and so that'll be half of cosine 3 theta plus 5 theta here, plus cosine of 3 theta minus 5 theta here, the half of cosine 8 theta plus cosine of negative 2 theta. Now the cosine of a negative, cosine absorbs a negative, it's an even function. So you get a half of cosine 8 theta plus cosine 2 theta. You have a difference of sign, sine 4 theta minus sine 2 theta. Well, how's that go? Sine minus sine. Well, from the sum to product formula, sine minus sine is 2 cosine average, sine of the half difference. So 2 cosine of average, 4 theta plus 2 theta over 2, sine of the half difference, sine 4 theta minus 2 theta over 2. This works out to 2 cosine 3 theta, sine of 2 theta. Here I have a difference of cosines. Cosine 1/2 theta minus cosine 3/2 theta. Cosine minus cosine. Well, that's just the oddball with a negative 2. Sine of average, sine of half difference. So we do that. Minus 2, sine of the average, theta halves plus 3 theta halves over 2, times sine of the half difference, theta halves minus 3 theta halves over 2. This comes out to sine theta. This comes out to sine of negative theta over 2. Now, negative comes out of the sign because it's an odd function, canceling this negative here. And so you get this equals 2 sine theta over 2. Okay. Oh, dear. Let me turn this thing off now just a second. It's ridiculous. There's got to be.